Hello students, Stride here again. Today we're looking at practice problems. Ten 10.3.2. Looking at here is off of page 338. So we go through these practice problems. We're going to be converting between mass of a compound and number of particles. And there is no direct conversion possible between mass and number of particles. But we can change between mass and moles, and then between moles and particles. The particles, or as we often refer to them, the representative particles, can be formula units, if it's an ionic compound, we might look at molecules. If it's a covalent compound, we'll look some at ions, atoms, and a lot of different types of particles we may have depending on what we're talking about. As we're converting between mass and moles, here, well, he's going to use the molar mass. And as we convert between moles and particles, we use Avogadro's number, 6.022 times 10 to the 23rd. So as we're doing problems today, we'll be using molar mass. And then we go on page 338, we have a practice problem, example number 9, given here, where we have 35.6 grams of aluminum chloride, and we want to change that into, for part A, aluminum ions, part B, chloride ions, and note the aluminum has a 3 plus charge because it was in group 13. The chloride has a 1 minus charge because it was in group 17, a halogen. And then the C, mass of formula unit. The textbook goes through routine. Gave it to you here of how to solve this problem. You can use their method, slightly different than the method I'll be showing you. Both work well. Mine just flows through a little bit better. We'll get rid of the problem now. Get it out of the way. And then we'll go through solving the problem. So first thing we're going to want to do is find the molar mass. on a periodic table, we want to look up aluminum, and we want to look up chlorine. Depending on the periodic table you look at, aluminum is one I'm looking at here, says 27.0, but I want to use, when possible, I want to use at least two sig figs, two decimal places. I'm going to use 26.98. If your periodic table happens to have 27.0, you can use that. Chlorine is 35.45. Then in the formula, there's 1 aluminum for every 3 chlorines. Now we do a little multiplying, and we add these two things together. Multiply, and add. Make sure you always are running these things through your calculator. It's 26.98 times 1. You don't have to enter times 1. Plus 35.45 times 3. And we get 133.33. Grams per mole. Then we do one of the problems, one of the parts out. We'll start by looking at and finding number of aluminum ions. So we start with 35.6 grams of aluminum chloride. And we change from grams to moles using our molar mass. And we just figured out there's 133.33 grams of aluminum chloride in 1 mole of aluminum chloride. Grams cancel the grams. So first, change from mass to moles. Then we're going to change substances. So 1 mole of aluminum chloride contains 1 mole of aluminum ions. Mole cancels mole. So change from mass to moles, change substances. Now we can change them to particles. I'm running out of room here, so I'm going to extend my bar down here. In 1 mole of aluminum ions, we have 6.022 times 10 to the 23rd aluminum ions using Avogadro's number. Moles cancel the moles. And we're ready for calculations. We take 35.6 divided by 133.33 times 6.022 times 10 to the 23rd. And we get 1.61 times 10 to the 23rd aluminum ions. Now, once you have one of the ions in the thing, the other one tends to be pretty easy. Now, you look at the example from the textbook, they go through a lot more calculations on it, a little different way. I just come back to what we just did. Get a new color here. And the only difference here is we're still going to start with this first part. It's all got to be the same. But this is the part right here this part here is going to change, this part. Because we're not dealing with aluminum ions now, we're dealing with chloride ions. But there are 3 chloride ions for every mole of aluminum chloride, because we got AlCl, 3. And then in 1 mole of chloride ions, there are still 6.022 times 10 to the 23rd chloride ions. So the thing we have to do, everything's the same except we change this 1 to a 3. So we're just going to take this answer times 3. If you still have it on your calculator, all you got to do is hit times 3. And we get 4.8. Now, I left what I had on my calculator, and it's telling me 4.82 times 10 to the 23rd. If you retyped in the 1.61, you're going to get 4.83. Either answer is okay. We can be off in that last significant digit, because that's estimated. Chloride ions. And in part C, we want to know mass of 1 formula unit. And there, what we do, we also got to do to find that mass of 1 formula unit. We take our molar mass. So there's 133.33 grams of aluminum chloride in 1 mole of aluminum chloride. But we know 1 mole of aluminum chloride is 6.022 times 10 to 23rd formula units of aluminum chloride. We use the phrase formula units because it's an ionic compound. The moles, cancel the moles, we get grams per formula unit. And then we just do a little division. And we take 133.33 and divide it by 6.022 times 10 to the 23rd. And we get 2.21 times 10 to the negative 22nd grams of AlCl3 in 1 formula unit. Okay, there's an example problem. I think we'll stop there for today. Next time we'll continue on this, and we'll be looking at 42 through 46 on page 339. If you really think you understand them, you can go ahead and try them. But they'll be coming up next time on what we'll be calling practice problems 10.3.3. So that's what we'll get next time. So that's it for now.